Mr. Mitchell here, Pre-Calc students. We're going to take a look at Section 2, Polynomial Functions of Higher Degree. Polynomial is a function that has variables as the basis and then has exponents that are constants. So when the highest power, that's what we truly want to look at, is even, it acts similar to x squared. So this is what x squared looks like. It looks similar to a parabola. And when n is odd, it looks similar or acts similar to x cubed. So there you can see what x cubed looks like. So we could get lots of different graphs. You can get an x squared type graph that looks something like this. That still acts like x squared. Or you could get a function that looks like this. That's similar to x cubed. All the stuff in the middle is controlled by some other things. But notice the highest power, this could be like x to the 6th. Or x to the 8th. And then this could be like x to the 9th. But it has some other things with it. So just some little examples there. Leading coefficient test. These are just some things to remember. We're describing end behavior. This is how we want to describe the end behavior. What does that mean? Look at the graph. We don't care what happens in the middle. We only care what happens on the edges. So what happens as you go to the left of this graph? It's going down. So as you go to the left, the graph goes down. What happens as I go to the right? As I go to the right, I go up. So infinity is positive to the right, positive up. Negative infinity is left, negative infinity is down. Just depends on whether you're talking about x or f of x. Remember, f of x is just y. So if n is odd, when you go left and you go right, you're going to have one direction each. So x is going to go left, x is going to go right. You're always going to do x left and right. It's just a matter of what y does. That's what you're really guessing or checking or trying to figure out. You're not trying to figure out x. X is going to go to the left, x is going to go to the right. See, look. Negative, positive, negative, positive, negative, positive. That's x is going to go to the left, x is going to go to the right because that's the end behavior. You need to judge whether it's going up or down, not whether it's going left or right. So when n is odd, the highest power is odd, you're going to have one up and one down. Okay? N is odd, you're going to have one up and one down. You need to figure out which is up and which is down. You do that by looking at the leading coefficient. All right, so when the leading coefficient is negative, it's going to go up to the left, down to the right. When the leading coefficient is positive, it's going to go down to the left, up to the right. Now, when we have a highest power that is even, again, you're going to go left, you're going to go right. What does it do up and down wise? Well, if the leading coefficient is positive, they're both up. If the leading coefficient is negative, they're both down. So when the highest power is even, you're either both up or both down. That's just something we can look at a graph and do it, but this is how we have to write this. Okay? Zeros. The graph has at most blank real zeros. Well, if whatever your highest power is, it has at most those many real zeros. So if your highest power is x to the n, it has n real zeros. And the graph has at most n minus 1 turning points. So I drew a couple graphs up here. So let's just say this was x to the 8th. This could have 8 real zeros. It has 8 zeros, but some of them may just be imaginary. And we'll get into that later in our chapter. How many turning points does it have? It could have at most 7 turning points. Okay. You see the turning points I drew? I drew 1, 2, 3, 4, 5. I have 5 turning points in my graph here. So that is 7 or less. Here, highest power I said was 9. All right, notice 1 up, 1 down because it's an odd power. Here's my turning points. 1, 2, 3, 4, 5, 6 turning points. Okay, that's less than 8. Remember, n minus 1. And this could have 9 zeros. I didn't draw it on an x and y coordinate plane. It could have 9 real zeros. It has 9 zeros, but again, some of them could be imaginary. Okay, so that's all this is saying here. Your zeros match the highest power, okay? And then your turning points have to be one less. Let's take a look at the next part. This is basically what we did last chapter with transformations, except for we're dealing with a different graph. So is x to the fifth related to x to the second, or x cubed? It's going to be related to x cubed because they're both odd powers. What does the negative do in the graph? We should know that. That's a reflection over the x-axis. It's going to reflect the graph and going to make it look like this. Because x cubed normally looks like this, so it's going to reflect it. So, which graph is related to this? Well, it's x to the fourth. That means it's going to be like x squared. What does the plus 1 do to the graph? That's going to be a horizontal translation. Which way are we going to move it? Left 1. So you see how important our transformation rules in Unit 1 are? They're not leaving. They're not going away. Every graph we work with is going to follow those transformation rules. All right? So now we need to look at the end behavior. So we could graph this, but it's x cubed. So x cubed is either going to be like this or like this. And again, I'm not worried about turning points because all I'm worried about is end behavior. Down here, I may care more about zeros and stuff like that. Which one is it? Well, we need to look at the leading coefficient. It's negative. So we're going to deal with, not this one, we're looking at, and I know that graph is really bad, but that's okay. So what does f of x do? So as x goes to the left, what does f of x do? I know in the notes we write f of x first. It doesn't matter which you write first, but it's as the x. As x goes to the left, what does f of x do? So go to the left of this graph. What happens as I start moving left? It goes up. And then as x goes to the right, what does f of x do? So go to the right on this graph. Again, this is a junky graph. It's terrible, but that's all right. We're only looking at the end behaviors. So as I go to the right, what does the graph do? It goes down. It's negative infinity. Again, we're just trying to decide what happens in the extremes, the far reaches. What happens far to the left, far to the right. All right, letter B. So what does this graph look like? It's x to the fourth. Well, think about what x to the fourth look like up above. Its a leading coefficient is positive, so x to the fourth looks something like this. It may have some other things happening in here, but end behavior, I really don't care about that. So as x approaches negative infinity, what does f of x do? So as you go left, what does the graph do? It's going up. As x goes to the right, what does the graph do? It's going up. Okay? So knowing what the graph looks like, I can talk about my end behavior. So now here's x to the fifth. What does an odd look like? Well, also having a positive coefficient. We just dealt with odd over here, an odd power. It's going to look like this. Again, I don't know what happens in here, but I'm not concerned about it. I'm worried about the end behavior. So as x approaches negative infinity, oops, sorry about that. What does f of x do? As you go to the left, what does the graph do? It goes down. And then as x goes to the right, what does f of x do? It goes up. All right, so that's end behavior. What happens on the extremes? Now we need to talk about zeros, finding the zeros. We'll look at doing it on the calculator. We'll also look at doing it by hand. So let's talk about this first one. Let's do it by hand. When you're finding zeros, you need to set the equation equal to 0. Especially if you're going to do it with algebra. So we're going to try factoring. What factors out of here? You can factor out a negative 2x squared. Right, they both have a 2. You want to factor out the negative so the leading thing is positive. So what do you got left? X squared minus 1. Now we need to solve these. 0 equals negative 2x squared. 0 equals x squared minus 1. So this factors again. So it's x plus 1, x minus 1. So my zeros down here are negative 1 and positive 1. And if I solve this, if I divide by negative 2, I get 0 equals x squared, square root, be careful, plus or minus 0. You can't get plus or minus 0, you're right. 0 is 0. But this is what we call a double root. So, I'm sorry, I didn't mean to say x equals a double root. X equals 0 is a double root. So, how many zeros did we say we should have? Well, we're going to have 4 zeros. It's a matter of whether they're real or imaginary. 4 zeros. 1, 2, 3, 4 zeros it matches. Take a look at letter B. Let's try to solve this by factoring method. Set it equal to 0. What can you factor out? Well, it looks like they share an x cubed. So that's 3x minus 4. Set each thing equal to 0. So if I solve this bottom one first, 4 equals 3x. So x is 4/3. Okay, that's one solution. How many should I have? How many zeros? 4. Are they all real? I don't know. We'll find out. So what happens here? Got to take cube root. So x equals 0. And that's going to be a triple root. It's going to happen 3 times. You're taking the cube root. If you're not sure, we'll find another method later. You get 0 and 4/3. You can find whether it's 0 again or if it's something else, if it's an imaginary number. All right? So let's go ahead and get our calculator ready. We're going to do letter C with the calculator. So I paused it and typed it in because it just takes a little bit longer to do with a mouse and everything. So I typed in my equation. So that's what we're trying to graph. And we can do it algebraically too. We just thought we'd do another one of these with the calculator. So I type it in, I graph it. So we're looking for where it crosses the x-axis. So it looks like this point and this point are the two that we're looking for. Now, how many should we have? We should have 3 zeros. Now, whether they're all real or not, we'll find out. So how do I find the zeros with a calculator? So second calc, the 0, and then you need to know left and right. So this is the point I'm trying to find. Go to the left of it. I know it's above it, but it is to the left. I don't care if it's above or below. I need it left. I hit enter. Then it says to the right. How far to the right? Just far enough. Far enough to the right. And then guess near the point. So we have one of our zeros at 0, 0. So that's one of them. I come back to my graph. I'm going to go second calc. I'm going to select 0. And then go to the left. This is the point I'm looking for. Go to the left, hit enter. And I got to go to the right and hit enter. And I got to guess near the point. So it looks like I wouldn't pay any attention to that 5. It looks like it's 1.5. So on my paper, I have another 1.5, and it's always comma 0 when you're finding zeros. Now, where's the other one? I should have 3. I only have 2. So it could be an imaginary 0, but imaginary zeros come in pairs, so it is not imaginary. Looking at a graph, anytime you have a parabola shape sitting on the x-axis, if you have a max or a min point sitting on the x-axis, that is a double or a triple or a quadruple root depending on the situation. So this point is a double root. It's also called a multiplicity of 2. It means the same thing. It just depends on which textbook or which teacher you're talking to. Whether you want to call it a double root or a multiplicity of 2, it means the same thing. All right? We could have solved it by hand, but this is just another ulterior method. So Questions? Please.